All right, welcome. Section 5.2, which is properties of rational exponents and radicals. 5.2 is a very important section, just like 5.1. If you don't understand this section, I'm a little bit concerned for you, okay? So what you have to understand about 5.2 is it's a lot of exponent rules, which you should have learned in Algebra 1. If you are behind and you don't remember those, you need to be going to the Math Help Center and coming to see me because it's not going to get any easier. Okay, basically I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 examples I'm going to work through here. Okay, I went example heavy in this video just because I think you really need it, especially with finals coming up and you all love those. So here we go. All aboard. We have, number 1, use the properties of rational exponents to simplify each expression. Okay, here you see that our bases of our exponents are not the same, so we can't combine. We also see that these are exponents, by the way. I know they're kind of hard to tell, but these exponents are not the same either. Okay, but we have this 5 on the outside, and the big bad math guys told us that we could distribute that 5 as a power to both of those. Okay, and when we do that, we multiply those exponents. So we've got 5 to the, well, 1/5 times 5 is 5 over 5, times 8 to the power 5 times 1/4 is 5/4. And here what you have to understand is that the 5, you don't really raise, it's like this. You've got 5 to the 1/5 all to the power of 5 times 8 to the 1/4 all to the power of 5. So don't multiply 8 by 5. I see that a whole lot. Don't do that, okay? Now we can simplify. 5 over 5 is 1, so really we've got just 5, times 8 to the 5 over 4, okay? You can either write your answer like that. Do not combine the 5 and the 8. Please do not. Oh, man, I'll have a heart attack, and I'm too young for that. All right, please don't do that. But what you could also do is 5 times the 4th root of 8 to the 5th. I'm fine with that as well, okay? So either one of those answers is fine with me. Normally in big ideas, if they give you fraction or rational exponents, they want rational exponents back, not radicals, but your decision, okay? On the test, I will accept both. All right, on B here, we can actually do this a couple different ways. I'm going to do it the way here that I think is easiest. I like to simplify and then expand. Some of you like to expand and then simplify. I think that creates way too big of some problems for us. So I'm going to simplify first. And what I mean by that is I see that both of these exponents here are to the power of 1/4. So I'm going to rewrite this as 56 over 8 to the 1/4. And then I'm going to raise all of that to the power of 3, okay, because I still got that 3 on the outside. The reason that I did this is because I know that 56 over 8 simplifies to 7, okay, so I can simplify this inside to be 7 to the 1/4 cubed. And then all I have to do is distribute that 3 inside and multiply it by the 1/4, so now I have 7 to the 3/4, and I can keep it like that, or you could write it as the 4th root of 7 cubed, and it doesn't matter to me which one you do, okay, again, just, you might have to play around with big ideas to see what they have for you, okay. All right, number 2 here. Number 2 says use properties of radicals to simplify, okay. So what we got going on here is probably a lot of different things, and you probably hate your life, and I'm sorry about that, but we got to do it. So A doesn't look too bad, mostly because our index, or indices, I guess I should say, are the same. So you learned this rule in class that said if you have a fraction, basically, of radicals, and you could write it as one radical, or one fraction underneath the root sign like this, okay? And the reason why you want to do that is because 192 over 6 actually simplifies, and it simplifies to 32, okay? And then what you can do is the 5th root of 32 is 2, okay? And if you didn't know that, you could make a factor tree, but I'm going to say that you believe me as of now, all right? And because we have an odd index, we're going to keep our signs, which is positive, okay? So there's that. B is a little different though, because 19 over 4 does not simplify. So we have to do something called rationalizing the denominator. And basically what that means, okay, we know that the index has to be the same. We have to somehow create a denominator that can be undone in forms of a radical. So we need to be able to fourth root something, okay? And the biggest thing that 4 goes into, that, or not the biggest thing, we don't want the biggest thing. The smallest number that 4 goes into that you can fourth root is 16. Okay, so we know that in the end, we want to get to the fourth root of 16. Why? Because you can fourth root 16 to be 2. Okay, you could have chosen bigger numbers, but I'm telling you, just find the smallest one that you can root with whatever index that you have. Okay, so then I ask myself, how do I get to the fourth root of 16 if I've got the fourth root of 4? Well, if you multiplied by the same thing, you multiplied by the fourth root of 4, you would get to the fourth root of 16. Now be aware that it's not always going to be you multiply by the same thing. Okay, it's whatever gets you to the thing that can be fourth rooted. Okay, so just be aware of that. But remember, whatever you do to the bottom, you must do to the top, or you don't have the same equation anymore. Okay, or expression anymore. So then when you do that, you can now say, okay, well, the old dead guy said, then you can look at that as the fourth root of 19 times 4, which if you plug that into the calculator is the fourth root of 76. And the fourth root of 76, just take my word for it for time's sake here, does not simplify, so you just leave it like that. And a lot of you at this point are like, Miss Bauckham, how do I know when I'm done? Well, let me show you. We wrote these down in class. Okay, the first thing is that the radicals or our roots are completely simplified. Okay, the fourth root of 76 does not simplify anymore, so we're good. The second thing said that there are no fractions underneath the radical. Well, even though we have a fraction, okay, the fraction itself is not underneath the radical sign. The only thing that's underneath the radical sign is the numerator, and that's okay, all right? And then C says there are no radicals in the denominator. Well, that's what we got rid of when we rationalized the denominator, okay? So we're done. Yay, team. Okay. If you were curious why 76 doesn't simplify, it goes down to 2 and 35, 36, 7, 38, and then 38 simplifies down to 2 and 17. Okay, so there aren't any groups of 4, all right, if you were curious. But anyway, C is a little bit more complicated when it comes to rationalizing the denominator because we don't just have one term, now we have 2. Okay, so we have to think what would get rid of this in the denominator, and I told you to multiply by the complex, not the complex conjugate, excuse me. Complex conjugates, you remember when we were dealing with i's, okay? So you can multiply by the conjugate of the denominator here, okay? And the reason that we can do that, it basically, if you FOIL this out, okay, the square root of 7 times the square root of 7 is 7. Plus 2 root 7 minus 2 root 7 cancels. Okay, you saw this in class, so then you're left with 7 minus 4. Okay, which then comes down to 3. Okay, so just be aware of that. And whatever you multiply the bottom by, you can also multiply the top by as well. You have to, or it doesn't work. So 1 times the square root of 7 plus 2 is still the square root of 7 plus 2, which still comes out to be here. Okay. And then that is all that you have to do. Okay, don't make it any more difficult than it is. Okay, we're done. We don't have any radicals underneath the denominator, or we don't have any fractions underneath the radical sign. We don't have any radicals in the denominator, and our radicals are completely simplified. You can't simplify the square root of 7 anymore. Okay, so just be aware of that. Perfect. Sweet. Okay, moving on. D here. Oh, I thought we already had it. Oh, no, we didn't. Okay, D. The fourth root of 48 minus the fourth root of 3. Okay, now remember, you could only combine like radicals if they had a like index and like radicand. Okay, you can't combine things that are different in some way. Don't do it. Okay, so here what we've got is this. Now, the first thing you're going to want to do is simplify, because right now we don't have the same radicand, so we can't combine. So we come over here, we do 48. Well, 48 breaks down into 12 and 4. 4 goes down into 2 and 2. 12 is 2 and 6. 6 is 2 and 3. We're looking for groups of 4, We've got 1, 2, 3, 4 2s, so we pull out a 2. 3 is all lonesome by itself, so it stays underneath the root. Okay, which works because then we have the same radicand and we have the same index here, so that's good. Okay, so basically it's like saying you have 2 fourth roots of 3, and I'm going to take one of them away. So now you're just left with 1 fourth root of 3. Now, of course, you don't need that one. You can just leave it like that, okay? Treat these like variables. If that confuses you and you're like, there's too many numbers here, I can't figure that out. If they have the same index and they have the same radicand, just treat them like variables, okay? Yeah, that's basically my 2 cents on how to make that easier, okay? All right, E, we've got the cube root of 27, d to the 12th. Now on here, okay, I know that you will probably know that the cube root of 27 is 3, but I want you to get in the habit of writing it like this. Keep it the cube root and write 27 as a cube like that, okay? And then we need to write d. If we're going to pull a d out, it has to be cubed at some point, right? That's the idea of a cube root. So we need to somehow cube the d, okay, in order to undo the cube root. But we have to ask ourselves, how do we get to 12, as close to 12 as we can without going over? Well, I know that if I raise the d to the power of 4, when you multiply these, that comes out to be 12. So we've got exactly 12, which is really nice. We won't, here in a second with f, we won't have that happen, and I'll show you how to deal with that when we get there, okay? So yeah. Okay, fantastic. So now what we can do is this cube root right here undoes all of those powers. So now we pull out what we undid, which was a 3 and a d to the 4th, okay? And because we had an odd index, we are done right there, okay? Now on F, we are not so lucky, and we're not so lucky because they don't go in evenly. Okay, so the first thing that we look at are numbers. Okay, we just got a 2 here. 2 can't be broken down anymore, so we just leave it. Okay, there's nothing that can be done. But then we look at the A's. Okay, well, if we're going to undo A, at some point it has to be cubed. And we have to ask ourselves, what multiple of 3 gets us to 13 without going over? Okay, and that would be 4, because 4 times 3 is 12, so that's 12 A's. But then we still have 1 left, so we're just going to write it on the outside just like that, okay? And then we do the same thing for B's. We know that if we're going to undo the B's, they have to be cubed at some point, okay? And we want to get to 3 without going over, so that means we just need 1, all right? And then we do the same thing for the C's. We know if we're going to pull out a C, it has to be cubed, so we want to get to 8 without going over, and we can only go twice because 2 times 3 is 6. And then we need 2 more C's to account for the 8 under there. So there is where we just tack on a C squared at the end, okay? And then we basically pull out everything that's cubed, okay? So 2 is not cubed, so it has to stay underneath the radical. There's an a to the 4th, though, so you can bring out the a to the 4th. Okay, I'm gonna cross them out as we go. You are still left with an a underneath. Don't forget about that. We can pull out a b, okay? And we can pull out a c squared. Now I'm going to show you how I want you to write this in a second. Mine looks a little bit cramped, okay? But and then we keep a c squared underneath as well. Okay, so you should have a to the 4th b c squared times the cube root of 2ac squared. Now you see how it's really cramped? I would then rewrite it to be a little bit neater, to be a to the 4th b c squared times the cube root of 2ac squared, just like that. Okay, make sure that I can tell the difference between the power on something and the index. If I can't tell the difference, I'm going to count it wrong. Okay, all right, 2 more, we can do it. G has x squared over the cube root of y to the 13th. Okay, now this is one of those, again, you're like, oh no, a radical in the denominator. What do I do? Well, I'm here to tell you that let's see if we can simplify first. If you can simplify first, your life is going to be much, much easier. Okay, and by that I mean, well, x squared has to just stay x squared. We can't really do anything, okay? But then down here, we can rewrite y to the 13th to some power of 3, and the closest we can get to 13 without going over is 12, and then we're just left with 1 left, okay? And the reason why this is exciting is now we can pull out 4 of those y's, and now you were just left with the cube root of y, okay? And you're like, but that doesn't look any better, Bach, and why would we do that? Well, let me tell you. Because now, okay, remember, we have to somehow get rid of that underneath there, okay? And the thing, obviously the y to the 4th is still going to be left. Okay, so we got to have that left. But if we want to undo a cube root, whatever's underneath has to be cubed, right? Sorry, you can't see. Whatever's underneath has to be cubed. So we need to end up with y cubed underneath, right? So that when we're done, all we are left with down there, okay, so the cube root undoes the cube, and then you're just left with y, which then you're just left with y to the 5th. Now, I know I've gone really, really far into the future here, but do you see what I'm trying to get done? Okay? So now we have to figure out, okay, well, how can we get to y cubed? Okay, well, we have 1 y underneath. We need 2 more, so that means that we need to multiply by the cube root of y squared. And whatever we do to the bottom, then we must do to the top. Okay, so now let's make sure this works. We brought our y to the 4th along. The cube root of y times the cube root of y squared is the cube root of y cubed. Awesome. So it worked. Now let's do the top. Because we have unlike terms, we're just going to keep them as x squared, cube root of y squared. Okay. And then we've already kind of done this part, but the cubes cancel, so now you're just left with y. And the numerator just stays as is, x squared, cube root of y squared. Okay? And there's nothing else that you can do to that numerator. It just stays like that. I know it looks ugly, it looks messy, but guess what, friends? There's nothing more that you can do. Okay? I would just keep it just like that. I guess you could, well, no. If you wanted to, I would probably, because that is so messy, I'd probably accept it like that. But if you wrote it like this, which is x squared y to the 2/3 over y to the 5th, okay, what would happen if you tried to subtract, okay, because 2/3 minus 5 is a negative number. Basically meaning that you're going to get a fraction down here. And if you have a fraction as an exponent, that means you have a radical in the denominator, okay? And you can't have radicals in the denominator. So that is why you stop here, okay? Do not go on. But I am glad that I showed you that, because a lot of you are going to say, oh, you've got y's on top and on bottom. Well, I'm telling you, if you subtract, you're going to end up with a negative fraction. And a negative fraction means that you have a radical in the denominator. Do not do that, okay? Leave it right there. Okay. All right, last but not least here, we can do it. We have 16 times the 4th root of 3p to the 6th minus p to the 4th root of 48p squared. Holy moly. Okay, well, we know our indices are the same, but our radicands are not, so we have to somehow see that they are. Let's see if we can simplify anything. 16 can stay on the outside there. Okay, we still got the 4th root. That can't change. 3 can't change, but we could write this as p to the 4th times p squared, right? Because there's 6 of them, so there's 4 of them. There's p squared. I wrote it like that, so maybe I could pull out a p or 2, okay? Minus, the p stays on the outside, 4th root of, okay, well, if you actually do the math, 48 can be written as 2 to the 4th. We're just going to take my word for it for right now, okay? And then it's actually 2 to the 4th times 3 if you work it out, okay? And then you've still got the p squared underneath. And so what happens then is we can pull out 1p. So we've got 16p times the 4th root of 3p squared minus, you can pull out a 2, okay? So I've got 2p times the 4th root of 3p squared. And now what's really awesome is that our indices and our radicands are the same, okay? So now we combine like terms. 16p minus 2p is a whopping 14p, and then because everything else is the same, you just keep it. It's just like an x, okay? So think of it like this. If you're confused, if you take 3x minus 2x, okay, it's just x. It's not like the x disappears, okay, because you subtracted, all right? You just take it and you combine their coefficients. It's kind of the same thing here, okay? And that is where you'll stop, okay? If you bore with me till the very end, you are going to be very, very happy with the results on your test, hopefully, okay? This is your last big chance to boost your grades, so come in and see me if y'all need help. Okay? I care about each and every one of you. Anyway, I'm out. See you in class.